Hi everybody. In this video we will review some circle geometry, and there will be 5 problems, and I encourage you to pause the video, solve the problem on your own, and then watch the video to just review important concepts. Okay, let's begin. In this problem right here we notice that we have 2 rays that are tangents, and let's write down over here what are the key geometric ideas. There might be one, there might be several. So the fact that we have tangents to a circle, we know something about the relationship between this tangent, this ray, and the radius of the circle at the point of tangency. And that relationship is that this is perpendicular. So one important key idea is the relationship between the tangent to a circle and the radius, and that is a perpendicular relationship. The second idea that is important here is we notice that we have a quadrilateral. And so we know that the sum of the angles in a quadrilateral is 360. So in order to solve this problem, I can set up an equation that would find me this angle right here, which I could call my question mark. And the last important point that we know is that there is a relationship between the central angle and its measure and the inscribed, oops, I didn't mean inscribed, I meant intercepted. Let's erase that. Intercepted arc. So the inscribed angle, I keep saying inscribed angle, it's my favorite word. The relationship between the central angle and its intercepted arc is they have the same measure. Okay, let's finish this problem. So now I know that sum of the angles in quadrilateral is equal to 90 plus 90 plus 54 plus my question mark. And when you solve this equation, you will get the question mark, which is the central angle, and the central angle has the same measure as the intercepted arc. Got it right. And that answer is 126. Okay, in this problem right here, we see that we have a triangle that is inscribed in a circle, and then we also notice that it's inscribed in a very particular way. The diameter is one side of the triangle. So let's again list our key ideas. So there's something important about inscribing in a semicircle. That has important consequences about this angle right here. I also notice that I have angle C right here, and then I have its intercepted arc over here. Remember what I suggested in class is when you are looking for inscribed angles, go ahead and highlight it and extend it beyond the circle so you can clearly see where it cuts the circle. And there's my intercepted arc. So there's a relationship between that intercepted arc and this inscribed angle. Let's write that as key idea number 2. So inscribed angle. There's a third key idea, and that will help you solve for B. What is that key idea? Go ahead and solve, and let's find out what our answers are. Here's a third triangle, and again, let's list some key ideas here. So we notice that this triangle is inscribed in a different way. It is inscribed such that the center of the circle is inside the triangle. I still see some intercepted arcs and angles though. So if I go ahead and intercept or draw my inscribed angle, I see that that angle intercepts this arc. Okay, so I know that one key idea is going to be finding inscribed angles and the relationship between the inscribed angle and its intercepted arc. Here's another inscribed angle, and do you see its associated intercepted arc. It's right there. Okay, so we can talk about the other key ideas. You have some options because we can talk about the sum of all of these arcs in a circle. What does that measure? We could also talk about the sum of the angles in a triangle. So either one. So I'm just going to write triangle sum, or let's just call it measure of the circle. Let's move on to the next problem. Check your answers and let's move on. In problem 4, we see that AD is a tangent and AC is a diameter. Okay, so we put all that together, and a key idea, again with tangent, there's something about tangents to a circle. Mark it. So I'm going to go ahead and mark it. I know that this is perpendicular. That means that this is a right triangle. And that means I know some answers. So let's look at a couple more ideas that are important here. If I want to be able to find the measure of angle C, I'm looking at angle C, and I notice that if I do this, I see that there's an arc that is cut off. And here's the corresponding intercepted arc. So if I'm able to find the measure of angle C with the triangle sum, I could find the measure of arc AB by using the inscribed angle theorem. And then finally, to find the measure of arc CB, we know something about the measure of an arc of half the circle. So let's list that. I don't know how to call it. Semicircle arc? How's that sound? Okay, solve the problem, check your answer, and let's move on to the last one. In this last problem, we see that we have a very special quadrilateral. Remember that fancy term for it? That is known as a cyclic quadrilateral. It is inscribed, oh no, I'm running out of space. It is inscribed in a circle. And we found out that there was a special relationship between the opposite angles in a cyclic quadrilateral. 106 and B have a special relationship. I'm going to outline something, and maybe we'll remember what our special relationship is. Here is angle 106. And I extended the angles, the sides, so I could see the intercepted arc. The intercepted arc is right there. Now I'm going to mess up my diagram here. It's going to get a little messy. Check out where angle B, where that cuts off. I just threw the frisbee. So check that out. And then here's its intercepted arc, corresponding intercepted arc. So we notice something about the opposite angles, both inscribed, and how much of the circle they cut off right here. Will that help you to find the measure of A and B? So I'm going to add to my key idea list about the opposite, ooh, that's big, opposite angles in the quadrilateral. And this is only for a cyclic quadrilateral. Okay, check your answers, and I'll see you in class. Bye.